Hello everyone. Welcome to part 5 of the chapter 5 videos where we're going to talk about some counting techniques. And so what we've seen up until now is we've been calculating some probabilities, but always whenever you're calculating the probability, that general kind of a probability of something event, it was going like the number of ways that this event can occur. And then we were supposed to divide by the total number of possible outcomes. However, in all of the cases that we've seen so far, it somehow has been clear the total number of possible outcomes, how to find this. Whenever we get into some of the heavier counting techniques where we actually need to apply some techniques to be able to count things, what we're talking about counting most of the time are the possible number of outcomes. And sometimes it's not always so clear-cut, and that's why we need some of these rules, and we'll look into some of these terminologies that we use, and also some of the ways that we can use the calculator to count things. Now, the most general and basic rule for counting, we call it the multiplication rule, but it's not so important what we call it. The idea is that a lot of the things that we're trying to count, it's possible to break up a more complicated scenario into a few specific tasks. And this word tasks, I'm going to use it to describe these little individual things that are happening inside of a more complicated situation. And so I want to, just kind of by way of an example, think about what it means, tasks. Right here, this example, we're thinking about how many one-topping pizzas can you make from 5 toppings and 3 different types of crust. And so here, maybe if we were thinking in terms of probability, you might say, like, what's the probability if you just randomly press buttons on this ordering pad? What's the probability that you choose a thin crust pepperoni pizza? Well, we need to first figure out how many possible pizzas there are that you can make in general. And so when it comes to tasks right over here, one of the tasks would be to choose one of the 5 toppings. This would be like task number 1. And then there are 3 different kinds of crust, and so that would be like task number 2 would be choosing the crust. And what it means as far as the multiplication rule, having these tasks, is that to figure out how many total possible pizzas we have, we just need to multiply how many ways we can accomplish task number 1 times how many ways we can accomplish task number 2. And sometimes the tasks, it doesn't have to be always in the same way. This example with the pizzas, it's more clear-cut probably what task 1 is and what task number 2 is. But we can have a situation that's made up of a bunch of different tasks, and the total number of possible outcomes we will get just by multiplying how many ways there are to do each one of those tasks. And this is also, there's a way that we could illustrate this kind of a counting procedure, which is that these tasks, we could illustrate them like with a tree diagram, where when we choose the 5 toppings, we're choosing one of the 5 branches over here coming off of this tree. And then from that topping, whichever topping we choose, there are 3 different crusts that we can choose. And so there end up being, from each of the 5 toppings, the same 3 crusts that we can choose. And then the total number of possible outcomes that we have, or the total number of different pizzas we would get by just counting the ends of these branches, how many final terminal points there are over here. And just by counting them, we'd see that there are 15 of them. But of course, the way we can get it is by multiplying the 5 times the 3. And 5 times 3, that's 15. There are 15 different pizzas possible. And in the same way, if we're going to make a meal where there are 3 choices for appetizers, that would be choose your own adventure on these 3 different branches over here. And then from each appetizer that we can choose 4 different entrees. And then from each entree, we can choose 2 different desserts. And if we just made this whole tree diagram, it would have a bunch of endings. And in fact, it would have 3 times 4 times 2 of them, which is 24. So there are 24 different meals that we can choose, because there are 3 ways to accomplish task 1, 4 ways to accomplish task number 2, and then 2 ways to accomplish task number 3. And this, choosing the meal, it's made up of those 3 tasks. And we have another example, which still, we can break it up into tasks. Here there might not just be one way to do it, but I'm just going to show the way that comes to me first. We're trying to figure out how many license plates we can form that contain 3 letters followed by 3 numbers. And of course there are 26 letters in the English alphabet, so if we're going to choose a letter right here, and notice for this one we're allowed to repeat for this license plate, there are 26 ways to choose the first letter. And I'm going to split this up into 6 tasks over here. Task number 1 is choose the first letter. Task number 2, choose the second letter. And then we've got task number 3, 4, 5, and task number 6 would be to choose the final number over here. And for number 2, it's still letters, so we can choose 26 letters. There's 26 letters to choose from for the third one. And then there are 10, it says numbers, but it's going basically by digits, right? Because we can have the digits 0 through 9, so there are 10 of them. And then we can choose 10 different digits that can go there and 10 different digits that can go there. And so to come up with the total number of license plates, we just need to multiply all of these. And if we multiply those, we end up getting 17,576,000 different license plates that are possible. Now, in this next example, this is going to be a case where no repeats are allowed, and we're getting close to this idea of what we call permutations. It has to do with no repeats allowed, but I want to just try this example, and we'll see this. It's going to become a familiar kind of a pattern over here, what happens with the numbers, because task number 1, we still need to pick a letter, so there are 26 letters to choose from. Now in task number 2, to choose another letter over here, we're not allowed to repeat, so we don't have 26 to choose from anymore. Now we can only choose 25 of them. And then we have now even one less letter to choose from, so now there are only 24 letters to choose from for the third slot. And then the same kind of a deal with the numbers. We can choose any of the digits 0 through 9 for the first one, but then once we've already filled this slot, now there are only 9 different digits left available. And after these 2 slots, now there are only 8 that are available. And so to make license plates without repeating, we should multiply all of these numbers, and that gives us 11,232,000, so a lot less. Now, we're going to introduce a terminology here, a new vocabulary word, which is called permutations. And you may have heard this used in English before, something about permutations, but it's basically just putting things in different orders. That's what it means. A permutation is a specific ordering or a specific arrangement of items. And we're going to be able to count permutations, but the idea is that we need to understand this idea of permutations because it's used all of the time in counting. Whenever we're trying to count the number of ways that we can do something, a lot of times what we're trying to do is just put things into different orders. And in general, you know, we might have the letters ABC, for example. We can just change this order and get a new permutation. It goes like, maybe we could rearrange, we can switch the B and the C and get ACB. Or else we can start with the C first, and when there's a small number of things, we could actually just list all of the different orderings. This is all of them. This is all the ways that we can rearrange the letters A, B, C. Once we get more than about 3 things, it's going to start to become a very tedious, very difficult task to try to put these into an order. But there's a formula for how we can count the number of ways that we can put things into order. And I'm going to write the formula like this. There's a couple of different notations that we can do to describe a permutation. Here what this one's saying is the permutations, we're choosing from a big group of n things. That's how many things there are that we're going to choose from. We're going to choose r of them that we're going to rearrange into different orders. And for example, here we've chosen from 3 things, the letters A, B, C, and we've put always all 3 of them into these lists. If we were choosing just from the letters A, B, C and only choosing 2 of them at a time, then that would be a different list. That would be like AB, but we could also make AC, and we could also make BA and BC. These ones are, I meant to say BC. These ones are permutations that we're choosing from a list of 3 things because it's the letters A, B, C, but we're only choosing them 2 at a time to put into different orders. And we could get, there must be a couple more of them here. And it would be interesting to note that there's actually the same number of ways that we can put these, the same number of them That's kind of interesting, but that's what it means, this notation. In the calculator, it looks a little bit different. See, if we go to math over here, there's a button for it. Math, we can go to the one here that's called probability. We want to go over to that one. And it's that first option there. It goes in PR, and you have to, whenever you're trying to calculate this one, you have to put the N number, the number of things you're choosing from, into the left of this symbol, and you have to put the R on the right side. So we'll see how to use that here in a second. But the formula in general, if we ever had to do it from a formula, what we put on top is N factorial, and on bottom it goes the difference between N and R, and then factorial. And if you're not familiar with this symbol factorial, what it means is this is just a shorthand for multiplying all of the numbers that start from this number N, and you multiply as you're counting down. So it'd be N factorial like this. It means N times 1 less than N times 2 less than N, all the way up until you get to 2 and then to 1, like this. And so we can have, for example, like 4 factorial. It goes 4 first, 4 times 3 times 2 times 1. And this is how we use just the formula, but if we want to calculate one of these like what we were doing over here, we saw there were 6 ways to rearrange 3 things, choosing them 3 at a time. So that was kind of like this thing, permutations, choosing out of 3, choosing 3 of them at a time. And we can do that by putting permutation with 3 and 3, and it would count them for us. There's 6 ways to do that. All that does is it plugs it into the formula and calculates this for you. But here, why don't we try a couple of these examples. We've got this: when you're shopping for a bank, and there are 3 different banks in Plano. If you want to visit all 3 banks, how many different routes are possible? So I think the idea here is that there are 3 banks like A, B, and C, and we're going to visit them, so you could choose basically which order you want to go to. Do you want to go first to A, and then to B, and then to C? Or do you want to go first to C, and then to A, and then to B? What it comes down to is this feels like we're counting how many different ways we could put A, B, and C into orders, choosing all 3 of them. So we're looking for this kind of a thing. The one that we just calculated, which there should be 6 ways to do it. How many permutations we can make that are 3 items long out of a total list of 3 items. Now we're going to get more of a new one, because here we're trying to find out how many ways can a president, vice president, secretary, and treasurer be chosen from 10 committee members. So if we've got 10 total members, and there are 10 of these people, then we're choosing, this will be the N, it's going to be 10. We're choosing from a list of 10 people, and we're going to choose them 4 at a time, because we're going to choose a president, vice president, secretary, treasurer. That's 4 of them. And so that's going to be the little R is 4. That's how many we're choosing at a time. Now it's not okay just to figure out how many different groups of 4 people we can choose. Here we're doing actually permutations, because the order matters. And that's something about permutations. I will put it over here, which this is a big thing about permutations, is that the order matters for permutations. Because we're going to see something here in momentarily that are called combinations, and that would be a case where order does not matter. And so we'll see some examples for that one. But for this, we just need to calculate it. And so I'm just going to reconjure the permutations icon. We want to do permutations of 10 things, choosing from 10 things, choosing them 4 at a time and putting them into different orders. There are going to be 5,000, this little thing, 10P4 goes, there are 5,040 different cabinets, as it were, that we could choose from this group of 10 committee members. And we could also do any of these examples in a very similar way, but I want to look at this example. It says, how many different ways can 7 different books be arranged on a shelf? And what it comes down to with the formula, something that's important to notice about the formula, is that here we're rearranging all the things. So we're choosing from 7 things, and we're making our permutations are 7 things long. And so this is going like 7 permutation with 7. If we plug this into the formula, it's going to go like 7 factorial over 7 minus 7 factorial. And on bottom we're getting 0 factorial. 0 factorial actually is just 1. It's important to know that it's defined that way because it doesn't necessarily make sense that 0 factorial should be anything at all, but it's actually just 1. 1 factorial and 0 factorial are both just 1. But in general, what we're coming up with is that number of permutations, it just goes 7 factorial. And if you think about it in terms of the tasks, we're rearranging these 7 things on a bookshelf. And so there would be basically a task that you need to figure out which book is going to be on the far left. And you would have 7 things to choose from to put there. But once you have that book in place, there's only 6 books to choose which one's going to go next to it. And going down, it would end up being in the last place, you only have 1 book left that's not already been put into position, so there's only one way to do the last task. And then when we multiply all these, this is literally just 7 factorial. It's 7 times itself counting down. And there's a factorial button in here. I want to just go to 7, then go into math. If we go over also to probability again, and we go to number 4, there goes factorial. And that is 5040 again. But that was just another way to solve this problem besides just plugging it into the calculator. That was getting a little bit dull for me, just plugging them into the calculator over and over again. But anyways, we're going to see now this word combinations that I alluded to earlier. A combination is still choosing R items from a big group of N items where the order does not matter. And so whenever the order does not matter, that's when you're dealing with combinations. And so say if we're just choosing 3 letters from the alphabet, then we're choosing out of all 26 letters, and we're going to choose maybe 3 letters from the alphabet. If we chose A, B, and C like this, that would be the same combination as CBA or as BAC. These are all just the same combination, but they were different permutations. And so sometimes whenever you're reading the problem, you're trying to think about should it be a combination or a permutation. You just have to decide whether the order matters. So for this first example, figuring out how many ways can you pick 6 committee members from a group of 20 people. And here they're just going to be 6 committee members. They're just generalized members. We don't have roles like president, vice president, stuff like that. We're just forming a committee, so they're all going to be equal members. That means that if you choose, Bob and then Sally, that's the same committee as if you chose Sally and then Bob. The order doesn't matter. And so this is going to be a combination. Here we have even another notation because we could have, we're choosing out of 20 people and we're going to choose 6 of them, and the C stands for combination. You also could anticipate seeing some kind of notation like this. And then there's one that is even, to me, more common, where you just put some parentheses and you put the numbers in there stacked like this. And the way you would pronounce this is 20, choose 6. So how many ways can you choose 6 things out of a list of 20? And this, it has also a calculator button in the same, it's right next to the permutation one. And if we do 20, choose 6, there are 38,000 ways, 38,760 ways to do that one. What about how many different random samples of size 5 could you obtain from a population whose size is 30? And we're assuming here that this is going to be a sampling without replacement so that it can be a proper combination. And we are choosing from a population of size 30. We're going to choose a sample of 5 people, or else 5 things. We don't know what this population is. And what do we get from that one? It is 30, choose 5. And there are a lot of ways that we could get that sample. There are 142,506 ways that we could choose that one. And then these examples that follow there, they're pretty much the same. But I want to look finally at a probability question having to do with permutations and combinations. This is saying that the New York lottery, it's going to be framed like this. You can pick 6 numbers from the numbers 1 through 51. And of course, the numbers cannot repeat. This is when they're drawing the numbers, there's no replacement. And so this is going to be, since order does not matter, apparently, then this should be a combination. And the number of combinations that there are, we're choosing from the numbers 1 through 51. So you have to think about how many numbers are to choose from. And it seems like there are 51 numbers to choose from. So we're choosing from 51, we're going to choose 6 numbers. And then we're going to see how many different lottery tickets there are that we could choose, how many different sets of numbers. We're going to choose 6 out of 51. And there are a fair amount. We're getting here 18,009,460 different number combinations. So the probability of winning, of course, to win you have to get the exact right one, and so there's you have to think about this one, because you're able to choose your numbers in any order. And so the numbers that you choose, the 6 numbers that you choose, they can actually be jumbled up. Those are going to be like the permutations of 6 numbers. Did you choose the numbers like 1, 3, 5, 7, 8, and 9? Or if we just rearrange these, like switch the 3 and the 1, this is still a winning ticket because you got the correct 6 numbers. And so the number of ways that you could win are the number of permutations that you can have of your 6 numbers that are the winning 6 numbers. We're going to take that set of winning numbers and permutate them, which there are 6 factorial ways to do that. That's how many ways to rearrange, I'll say rearrange these. Rearrange that winning ticket into this many different ways, and then that was out of, it's actually faster to write this right now. That's how many total combinations there were. So why don't we give it a shot? We're going to take 6 factorial, and I meant to put a 6 in front of this one. 6 factorial, and then divided by the answer that we just got from this one. It's still very improbable, but we're getting this answer like 3.99. It's going to round up. So I want to go to 4 decimal places, and so we'll actually just call this one 8 like this. And then when it goes with the e to the -5, what that means is times 10 to the -5th, which means we should move the decimal place 5 places to the left. And so if we did that, it would go 1, 2, 3, 4, 5. And then we're getting zeros in between. So it's going actually, if we rounded to 4 decimal places, we would just get 0. And so we should call this one, I'm going to round to 5 decimal places just so we can get 0.00004. That is the chance to win, or else we can take this scientific notation. It would be highly improbable. But anyways, that's permutations and combinations and counting techniques. Sometimes it takes quite a bit of thinking. You got to be a little bit clever sometimes to figure out how you're going to count this situation. How can you split it up into tasks? When does the order matter? When does the order not matter? And then multiply all your tasks together. You're going to have it, because most of the time, we're having to use this idea of combinations and permutations at the same time we're using it, in conjunction with the idea, that multiplication rule, where we're using the tasks. So it can be a little bit tricky, but I hope that this helped explain a little bit of the ideas. And that does it for Chapter 5 in general. So I'll catch you all in the next one. Thanks.